Okay, so looking at conditional statements. Now, this is perhaps excessively complicated set of conditions, and it's possible to make this a bit simpler. So we have a kind of tree of decisions where you've got one branch here, then another branch, and this branch in turn is divided into two branches, this branch and then this branch, and so on and so on. So it's a tree structure. It's better to make it into a linear structure. And what I've done here in the code is to make this into a series of tests which are executed one after the other. So first of all, we read in the mark, the student mark, and the default result is you get a grade A pass. And if the mark is greater than 100, then there must have been some error. So our result is that. On the other hand, if the mark is less than 70, we change the mark to be B. If the mark is less than 60, we set it to be C. If it's less than 50, we set it to be D. If the mark is less than 40, we set it to be fail. And if the mark is less than 0, then again, it's an invalid mark. Now, the effect of this series of tests is that if we have a mark of, say, 55, then first of all, result is set to A. This is not true. This is true, so the mark is set to B. This is true, so the mark is set to C. This is not true, so the result is not changed. And this is not true, so the result is not changed. This is not true, so the result is not changed. And the end result is that you'd end up with a mark of C, which is correct. So this code is simpler in some respects in that we don't have this branching of nested statements. Each statement here is only nested one level. So we have the conditional statement, and its branch, its sub-statement is simply the one statement there, and these separate tests are then executed in sequence. Okay, so let's see how that behaves. That's our student marks with a little bit more rational structure. Into the student's marks, so 55, we expect to see. And we should, of course, test this with various different marks. -1, it's an invalid mark. 10, 0, 23, 33, 44, oops, and you get an invalid if you enter a space. 55 we already tested, 66, 77, well, let's try 70. Borderline marks are often a bit suspicious, but there we go, we get the right answer. So it takes a little bit of convincing that to work out that this program does the right thing, but nonetheless, it seems to do the right thing. So when we create a program, we have to, of course, check that it is correct. We can check it by testing, which is just what I did there, running it with some example values, typical values. The borderline values of each test of each conditional should be tested, so 60, 70, 150, 40, 0, and so on. Those should be test cases. You should also test with other kind of reasonable values in the ranges. So that's an example of conditional, which does some significant kind of processing, really. And those are the results we expect. Now, conditionals are one of the most powerful statements, but another essential statement is the loop statement, and the loop statement repeats an action for a certain number of times. And in Python there's two versions of this statement. One is a bounded loop where we specify exactly how many times we should run it, and this is written like this: for an index I in a range from A up to B, including A and including B, where A and B are usually integers, execute the statements with I equals A, then with I equals A plus 1, I equals A plus 2, and then finally with I equals B. So this is a loop, and we can use this to add up a range of numbers, for example. Look at some numbers. So this is a program which reads in a number and converts that to an integer, as we've seen before. We expect to have an integer there. We keep a running sum, and that variable sum holds initially 0, and for each time we go through the loop it increments the sum by the index. So the idea is that first of all I gets the value 1, then 2, then 3, and finally up to n. So what we're summing here is the sum of values 1, 2, 3 up to n, which is what we wanted to do. So the part here of the program is the actual loop, and that loop is executing the body n times. We have just one statement, which is the loop statement, similar to one statement which is the conditional. It has a substatement. That substatement is executed for the number of times that the index has values in the range. So going from the starting point 1 up to the end point n. Even though this is written as n plus 1, it means values up to but not equal to n plus 1, which effectively means up to and equal n, because these are integers. Okay, let's see what that does. And let's enter 10. Each time around the loop, it does report what it's done already. So it reports that it's got a running sum, and it's starting at 1, and it goes up to the given value. So sum up to 1 is 1, 2, 3, 3, 6, and so on. And finally, sum up to 10 is 55. And the final answer is then 55. You can do the same with any numbers. Once you get larger numbers, then the computation takes a bit longer because it's having to iterate 100 times in this case. If I gave it 1,000, the delay is appreciable. You can actually find out what the delay is. You can register that the time is taking to add up to 1,000. It gives you a number of about 500,000 here. Now I could enter the value 1, in which case the loop is only executed once, but it still gives me a valid answer. If I enter the value 0, then it never gets executed and the sum stays at 0. And again, if I enter a negative value, the loop never gets executed because the n here is going to be less than 1. So that's the loop statement. This is a bounded loop statement where we know how many times the loop is going to be executed. And this is useful in many situations where we do know how many items we're going to add up or how many items we want to process. Okay, so to summarize, we've seen the simple program structure as a list of statements. We've seen integer variables. We've seen string variables. We've seen the assignment statements, conditionals, and bounded loops. In the next part, I'm going to go on to more complex kinds of loop and other kinds of statements which can be used, and also give some more examples.